Yes.
Okay, all right. So we were discussing applications of trigonometry in the last class. I hope we wrapped up the whole chapter. If you guys have any doubts in that, okay, do bring it on in the later classes or even in today's class. But let us sort of go back and see what we have completed so far. So can we say that we have completed applications of trigonometry also now? Yep, Seb and Umer.
Yes, sir.
Yeah, I guess. Is everyone tired today? Everyone is tired today. I got better and everyone is tired today. Everyone has had a long day and the class is also a little early today. So I guess, okay, Umer just left. Okay, let's see if he will be back. Okay. How is your sports week going, Zeb? It has started? It must have started, right? It's Tuesday. Mm-hmm. Okay. So we can start circles today, but let's wait for a few minutes and see if Umer and Saad are going to join back.
Sir, am I audible?
Yes, yes, you're audible. Just a moment. Saad is trying to join the class. Yes, you're audible. Hmm. Okay, Saad is also here. Am I audible and visible, Saad?
Yes, sir.
Am I audible and visible?
Yes, sir.
All right, all right. Saad, there is one thing about the homework. You uploaded the homework for the exemplar MCQs, but you just ticked the answer. You did not solve the questions. You're supposed to
Ah,
solve the solutions. I gave you MCQs because I wanted to see the solutions. That is how I will know, right, that you're able to solve them.
okay, sir.
Okay. It's
Okay.
it's nice. I mean, that's the right way to think about it, that it's MCQs. We will just take the answer. That is how we'll score in exam also. But the motivation to give that was to help you guys solve more often and to, solve good questions. So that was the intention. So the next time I give you MCQs, solve them. Okay. Do not just tick them. Okay.
Okay, sir.
Okay. All right. Umer is
Yes.
also trying to join back. All right. Let's. All right. Umer is also with us. All right, Umer, are we audible and visible here? Let us know and we will start.
Yes, sir.
Yeah, we are audible. Okay. So this is going to be our last week where we are going to, be fine with not being on the same pace. Okay. Everyone has had something or the else going on. Even I was sick and uh, everything else is going on, but we need to have a constant pace here where everyone is studying the same chapter and everyone is able to, follow up with that in the homework and in the class also. Okay. So Umer's and Saad's syllabus is almost completed, and then Zeb's syllabus is going to start after this week. So this week we will study circles and areas related to circles. Uh, or we can do one thing, is that we can study circles well, and circles is not that long of a chapter, but it will be completed very early. But if there are doubts from past classes, from ninth standard, there are some concepts and topics that are going to be a given fact that you understand them, so they will not be explained here in the textbook at least. So we'll take that also with us. But this is going to be the last week where everyone has some some kind of discrepancy here, that something else is going on and we are doing something. So let us try to get on the same footing here so that everyone is able to follow up and make the most of the classes that we are doing here. Okay, so one last thing about this, I did make a note of the syllabus here last time, that syllabus and the problems. Okay, so Saad, I did ask you to note down the problems in your syllabus, right? Topics that you find difficult.
Yes, sir.
Yeah. Do that once again. Take this week, analyze your past performances in your papers and whatever tests you have given up until now, and have some clarity over which topics you want to work on. Okay.
Okay, sir.
Because up until that point, until you don't have a plan, you won't be able to do anything in terms of improvement. We can't just you can't just be fine with that thing, that you do not know what you want to do and just continue doing what I'm trying to teach you here. Okay, I'm making note of everything that everyone has had problems with, so that would help you also and me also to uh, take up questions and topics. The last time you told me that you have had problems with word problems, and then in triangles you have had problems with application of similarity criterias, and then BPT. Okay, those are the two things I have made note of. And Zab's list is there with me, and then Umer's list is also here. In terms of Zab's syllabus, you haven't completed circles, right, Zab?
Yes, sir.
You haven't completed circles, coordinate geometry, and then areas related to circle, and surface area and volume also, right?
Yes, sir.
Okay, let me
Arithmetic
just,
progression, right?
yeah, arithmetic progression, quadratic equation also is not done, right? Okay, just a moment. Let me note that down. Coordinate, circles, areas related to circles, and surface area and volume also, right? Okay, all right. So, okay, so see, the topics that we have completed up until now, they are quite good in the weightage criterias. If you look at the weightage of these topics, okay, triangles over here would have one question from all of these will have at least two MCQ, maximum two MCQs, right? These are the topics that we have completed. Triangles will have one 3 marker, maximum of 4 marker, and then trigonometry would have a 3 marker, 4 marker. There are 2 mark questions also, right? If I'm not wrong, 2 mark short answer questions.
No, I have 3 4 mark questions.
3 and 4 mark questions. There are one MCQ, 1 mark MCQs.
I I don't have 4 mark questions. I have 5 mark questions.
You have 5 mark questions. Okay. No, in terms of board, we are talking about things in terms of board, because board will have a standard paper for everyone, right? Schools will definitely have their own pattern there. But in terms of boards and in terms of the syllabus also that is given, they can only make these kind of questions. Okay. Even in trigonometry, what happened was they gave a 3 marker question and a 2 marker question in 3 marks, like something that should have come in 2 marks, they gave it for 3 marks. Okay, let me just look at the board paper once. I'm mistaking this for. Uh,
And sir, our PA3 portion is a circles.
which syllabus? Sorry,
PA3 portion is circles.
PA3 portion.
Yeah, circles.
Okay, so PT3 or PA3?
PA3,
PA3. What is PA? What's the full form for that in school?
periodic assessment.
Periodic assessment. Okay, it's only circles.
Circles, yeah.
And what's the weight? What's the total marks for that exam?
20,
20.
20 comes to internals.
Okay, 20. So do they give you a breakdown of that 20 marks, or how is that?
No, it's full circle. Sir said you can expect
No,
exact the
no,
questions too.
that is clear. But did they break down how many MCQs and how many these questions you will have, or they just gave you 20 marks is going to be the weightage, and it could depend
Yeah,
on the teacher's mood of how they are going to, give the questions. Is that how it's going
yeah.
to be? Okay, all right.
No, I don't know. Sir said weightage is 20. That's all he
Oh,
said.
okay, okay. And when is the exam? What's the date?
Uh, it starts on 4th.
Starts on 4th, and when is math? When is your math exam?
I'm not sure, sir.
You're not. I mean, you did not give you the date sheet yet.
No.
No, okay. Let me know then. But if it's on 4th, and if you still, and if the first exam is also circles, we can still, complete the chapter because it's not lengthy and you have already done it, so we can cover it. Okay. Let me just look at the board weightage. We have 1 markers, we have 2 markers, 3 markers, 5 markers, and then 4 marks of case study. All right. So, okay. So according to that, uh, okay. Uh, we will have okay, one MCQ from each chapter, and then one 2 marker. We can. It's not really probable that we can get a 2 marker question from triangles. Let's say 3 marks, and maximum of 4 marker, or not a 4 marker. It's going to be 5 marks since it's the case studies are going to come in trigonometry, coordinate, and these three chapters are case study chapters. Okay, if you do not know trigonometry, then you will mess up in applications of trigonometry. So you need to consider applications of trigonometry as a whole chapter, trigonometry and applications of trigonometry, to be able to do case study questions. And then circles and areas related to circles are also case study chapters. Okay, you get a case study from circles, and then surface area and volume also they can give a case study. They haven't given in the last 2 years. I haven't checked the papers for other previous years, but you can get 3 marker, 4 marker here, of course, and then 3 marker and 4 marker and 5 marker, and then 3, 4, and 5. All right, and then 1, 3, and 4, and 5. And circles also, areas related to circle and circles. These two are combined so that they can make good questions on case studies. Okay, so 1 marker, 3 marker, 4 marker, and 5, and surface area and volume also. Okay, so we have completed many good chapters up until now. So I am saying that it is completed. But if you guys still have any doubts and you have individual doubts from these chapters, I'm reminding you again and again to bring them to me. Okay, and I will send a reminder to the team also today uh, to remind you and your parents of the same, because you guys are asking, but it's a reminder that I need to give to your parents also, that you have to bring in doubts, okay, actively, because we have not been taking many doubts. Now and then we have taken doubts, but it needs to be more actively done. Okay, we have completed many good chapters here, and you need to bring doubts from them and get it solved. And there is one way that will be assessed, because if there are weekly tests, there will be a weekly test soon. And if you do not perform in that weekly test from the chapter that is already completed, then that would become a question about how well we have studied so far and how well we are doing things. And whenever I'm making a paper for the weekly test, it's always going to be from the chapters that are completed. Okay, so that is why I'm emphasizing that you guys bring in the doubts. Don't be like you do not have any doubts. Go over the chapters and see if you haven't done something and you need to do something from that chapter. Okay, so let's start circles today. And Zeb is also here. She hasn't started circles, so we will start in a way that will also cover her chapter. And what about you, Saad? How is circles for you? Saad, are you here with us?
Yes, sir.
Yeah, buddy. How is circles for you? What kind of a chapter would you say it is? It is hard, or is it difficult, or what will you
No,
say?
sir. I guess circles and area related to circles are easy.
Easy. Okay. So we have to discuss some theory then, so that Zeb gets to follow it. and we will start with that. Okay, Zeb, did you study circles last year properly in ninth standard? Do you remember circles from ninth?
No, sir.
I cannot hear you, Zeb. Can you speak a little louder?
Yes, sir.
You did study circles well last year?
Yes.
Yes? Okay. Okay, so if you have studied circles well in the last class, we have three theorems that we will need in this chapter, and it's a very small chapter, not a lot of uh, s- theory that we will be using, very limited theory. So we'll have two theorems here, theorem 10.1 and theorem 10.2 and theorem 10.3, or is it a corollary? Just a moment. Let me copy these things here. We have theorem 10.1 and theorem 10.2. And there is one more.
Sir, zoom it, please.
Zoom, I will. I'm just copying it right now. I will zoom it and I will increase the font size also. Just a moment. 10.2, length of tangent. Okay, so we have these two theorems with us. Let me copy the figures also for them.
Sir, only two theorems, right?
Yeah, we only have two theorems. I was thinking there was something more, but there are only two theorems. Perpendicular to the radius theorem and then the length of two tangents from an external point, that thing. Okay, all right. Okay, is this visible now?
Yeah.
Yes.
Okay, so the first diagram is for theorem 10.1 and the second one is for theorem 10.2. Okay, so theorem 10.1 talks about a perpendicular, the tangent at any point to a circle is perpendicular to the radius through the point of contact. So what this is basically telling us and what a tangent is basically, let us go through that once and we will start. So we have a circle here, right? And we know that we studied about chords in our last classes in ninth standard. We studied about chords. Chord was what? A line joining 2 points, a line joining 2 points on a circle. 2 points. That is specific, 2 points on a circle. All right. So we have a circle over here, and then on the circle, you have one point that is, of course, very obvious to us, that is the center. So there are certain things that you have to. Okay, let's just go with the flow. We have center. Apart from center, the other points that we have are inside the circle. They can be points inside the circle. They can be points on the perimeter of the circle, right? And then they can be points outside the circle. So when we are forming a chord, we will take 2 points on the circle. Okay, these points will lie on the circle, and when we join these line, then with these points, the line that is joined is called a chord. It's specifically called a chord because it's inside a circle. If it's just outside the circle, it won't be called a chord. Okay, and then a chord that is passing through the center. Chord in the sense like there is a line that is passing through the center also, right? We call it a diameter. Okay, diameter is also a chord. This is also a chord, but we call it diameter specially. Why is this a chord? Because diameter is at the end a line that is joining 2 points. Let us call this E and F. Okay, diameter is joining two diagonally opposite points to the center, right? That is why it's called a diameter. And since it's a line passing through the center, we are calling it a diameter, but it's a chord. So chord is basically a line joining 2 points on a circle. Okay, those 2 points are going to lie on the circle, and then we have a special name for a chord that passes through the center, which is diameter. All right. Now, after this, what we did not study in the next, what we are going to study in this class is about tangents. Okay, a tangent and a secant. Okay, so tangent is going to be a line on so tangent is going to be a very specific line. So we will take a single point on the circle, okay, anywhere on the circle, on the perimeter of the circle, and we will draw a line through that point. Okay, so a line that is passing through only one point on the circle is going to be called a tangent. Okay, or you can also say that if it's passing through that point, it is also touching that point. Okay, so line passing through only this one point is necessary. Okay, Zeb, do pay attention to that one point on the circle. Okay, so if you are you can look at this these two figures and see that this particular tangent you can call xy a tangent because it is passing through one point which is P, and this particular point P is going to be called point of contact. Okay, this is a common point which lies both on the line and also on the circle. So a point that lies on the circle and then also on the line, which is the tangent, is going to be called point of contact. Okay, it is very intuitive to understand that that is going to be the point of contact. Okay, apart from that, there is theorem 10.1 which talks about how this point is going to be. The tangent at any point of a circle is perpendicular to the radius to the point of contact. Okay, so this whole long sentence is basically telling us that whenever we have a tangent to a circle, it could be over here also. Okay, we can have a tangent over here. So when we draw a tangent, we will be interested in the questions will be interested in finding us the distance between the center and the tangent. Okay, so we whenever we measure the distance, it's always going to be perpendicular distance, right? If you're measuring the distance between a ceiling, between your ceiling and your floor, you will never use the tape and measure it in a diagonal way, right? You will always use a straight line. You will always hold the tape in a straight line. Even if you're cutting something, you will always hold it in a straight line and cut it so that you get the shortest distance or the shortest length. So whenever you are doing that, whenever you're trying to find the distance, that point of contact will always make a perpendicular angle. Okay, so basically that is uh, the notion that we are interested here, that whenever we have a tangent, that tangent is going to be perpendicular to the radius. This radius is called a line. Now radius is called a line here because radius is a distance. We talk about radius as the distance from the center, right? And when we have this distance as radius, we rotate the circle, we rotate the line, and we form a circle. So that is why radius is not just the length but also a distance. Okay, and this distance is always going to be perpendicular, okay, to the tangent, which is this. Okay, you can also draw a tangent like this over here and then drop a line, drop the radius. Okay, so that is going to be perpendicular since both of them have a common point. This is going to be point P, and if you draw a tangent to point P, this is going to be perpendicular. All right, so is this clear, Zeb? About, right? Do let us know if you're not able to follow. We will slow down, we will take your doubts, and everything is going to be fair here. Okay, and when the classes start and resume at school and you take up this chapter, you can still have much more time to discuss it there. But I do think that school teachers will rush a lot because of only 2 months being left. Okay, but anyways, so let's move ahead. So this is theorem 10.1, that the radius is length and also a line. Okay, length and also a line. Both are the same things. Okay, so this is theorem 10.1. Now theorem 10.2. Now what theorem 10.2 comes to explain here is that to draw a tangent, we can only draw it with one point on the circle either, or we can have one point outside the circle. Okay, tangent is a line that passes through only one point. So if we cannot call this line a tangent because it is cutting the circle or touching the circle at 2 points. Okay, it's intersecting the circle at 2 points. A tangent only touches the circle at one point. So this is not a tangent, and we have a special name for it, that is secant. Okay, so a line that cuts the circle at 2 points is called a secant. A line that joins 2 points of a circle is called a chord. Okay, so this is how the hierarchy or the understanding of chord to the secant to the tangent comes to. Okay, so when we have this situation with us here, how do we draw tangents to a circle? One way is to just pick a point on the circle and then draw tangent to that line, through that point. Another way is to take a point outside the circle. Okay, and when we take a point outside the circle, we will we can only draw two tangents from that point. Okay, since tangent is a line that touches the circle at only one point, we can only draw this tangent. Okay, tangent PQ here, and then tangent PR also. So the length, this is the only way that you can draw two tangents. Okay, there is one another way that you can draw tangents. If you have two circles like this, then you can draw. Okay, you can draw two tangents like this. You will study this in the next standard, in 11th standard. If you study circles, if you take mathematics there, you will study this. Okay. This is one way. This is one another way. If you have a pair of two circles, this is how you will draw two tangents there. Okay. But this point is also outside the circle. So we can only draw tangents with either a point on the circle or either external points. So when we have an external point, from that external point, you can draw two tangents. And you can see here, this is one tangent, this is 3, and this is 4. For this circle it is 1, and for this circle it is 2. Okay, and this is point P. So this is how you can draw two tangents to a circle. All right, and you cannot draw more than that. And this particular length PQ is going to be called length of tangent. Okay, this length that you see here, all right, so this length that you see here, PQ, this is length of tangent, meaning the line that we have already studied distances up until now, right, from coordinate geometry. So this length, this distance between point P and Q is going to be called distance, and distance is basically length. So this PQ is going to be called length of tangent. All right, so PR is also going to be called length of tangent, and these two length of tangents are going to be equal, meaning PQ, if you are drawing two tangents from a particular point P to the circle, then this PQ length is going to be PR, meaning the length of two tangents is going to be the same. Okay. And then another thing to be noted here is going to be this particular angle is going to be 90° and this particular angle is going to be 90°. And we got that understanding from this particular theorem, theorem 10.1, that when you're joining the radius to the point of contact, that angle is going to be 90 degrees. Okay. These are the only two theorems that we are going to use in this chapter. Okay. And let us proceed with the questions. Okay, because that's the only theory that you will be using. Okay, let us take 10.1.
No questions.
Are there any let us take some basic questions and then let us start with 10.2. Okay. Okay, so tangent to a circle intersects it at how many points? 1 point, right? A line intersecting a circle in 2 points is called a secant, right? And then a circle can have how many parallel tangents? All right, so what's going to be the answer?
2.
Anyone? 2. All right, why can it not be 4? If I have a circle with me, can I not say that I have 4 parallel tangents? Can I call them as 4 parallel tangents? No, no, right, exactly. Because whenever we study pair of lines, parallel lines, we are always going to study we are always going to study them as parallel lines. They will not introduce any other line that is going to intersect them. Okay, and tell them that okay, this P and Q is also parallel. We are always only going to call two lines as parallel. Okay, so because of that, when we are making this tangent to a circle, we can either have these two parallel tangents or we can either have these two parallel tangents, and then say that we have at most two parallel tangents at a given point. Okay, at a given time. And then the next question is the common point of a tangent to a circle, and the circle is called point of contact. Okay, this is important to remember this technical term because it is going to be used a lot. Okay, now we have a situation here in question number 3. Let us try to draw it. So tangent PQ at a point P of a circle of radius 5 centimeters. Okay, first of all, let us draw the given information to us. We need a circle, and we are being told that a tangent PQ at a point P of a circle. So point P is of the circle. So this is point P. And we are being told that there is a tangent PQ. Okay. And then we are also being told that the radius is 5 centimeters. Okay, and radius O is 5 centimeters. So we drew that up until now, and then the next information is given to us that a tangent PQ at a point P of a circle of radius 5 centimeters meets a line through the center at O, center O at a point Q, so that OQ is equals to 12. Length PQ is.
Root
Okay.
119, sir.
Yeah, the answer we will do that, but let us also go through the process, right? So we are being told that this is the whole situation. We are being told that OQ is also 12 centimeters, okay, and this is 5 centimeters, and we are being told to find this distance. So we are going to use Pythagoras theorem a lot in this, because this situation will keep recurring. Okay, this whole right angle triangle situation is going to keep recurring here, over here. So we will use Pythagoras theorem a lot, and you will have to look for right angle triangles in this chapter and while solving the questions. Okay, so Pythagoras theorem will give you the answer, and that would be root 119. Okay, that is going to be the answer for this. Okay, let's take questions from exercise 10.2. Are you following so far, Zeb?
Yes, sir.
Yeah, this chapter is not difficult. It's really easy. So, let's work through it and be very proactive and ask any doubts that you have. Okay, we can take them later on also, but you can take them now also. Okay, let us take. All right, so we have this with us. From a point Q, the length of tangent. So we are drawing a circle again. Okay, from a point Q, the length of tangent to a circle is 24 centimeters and the distance of Q from the center is 25. Find the radius of the circle. All right, so from a point Q, so this point is of course going to be outside since length of tangent is being talked about. So this is point Q and this is going to be point P, let us say. So length of tangent is 24 centimeters, that is given to us, and the distance of Q from the center is 25. So this is the center to us, and this distance is also given to us as 25 centimeters, right? And find the radius of the circle. Okay, so this is what we need to find, radius, and we can find this very easily with what, Pythagoras theorem again. But did we make, if we consider, okay, this is 25, the line joining the center to the radius from a point
Sir,
Q, then
OQ is 24, PQ is 25.
the length of tangent is 24 centimeters and the distance of Q from the center is 25, right? That is what we drew here, right? Length of tangent is 24. Length of tangent to a circle is 24 centimeters and the distance from the center is 25. Okay, so we need to draw this a little differently. Only then can we find the answer here, or else we won't find the answer.
Sir, P should be parallel.
Yeah, PQ should be parallel. The tangent will be formed in this way, or yeah, if it is like this, only then can we say, because you cannot have any other side 25, because Pythagoras theorem won't allow that to happen, because hypotenuse will have to be perpendicular, right? And the first figure that we drew, it was like this, right?
Why is this wrong?
Mm, because at both the angles we were making 90-degree angle. We cannot have that, right? Almost 90. That is one reason I think. If we have a circle, let us make a clear situation here. If this is the circle and we are drawing if we take this tangent, oh my God, not so big of a line. Just a moment.
Yeah, so we can't have a triangle, can't have two 90-degree angles.
We can't have two 90-degree angles, or even if not that line of thinking, you can think it in this way that this figure is not right, because what we did here is when we had this circle with us, let us look at this circle, that when we had taken the point like this and we connected this in this way, okay, we are not given that we are drawing two tangents or anything like that. We have two situations, right? We can either have a tangent which is like this, right? Or we can have a tangent which is at a certain inclination to the circle in this way, in this situation. When we draw this and we have the center over here, so this would be the case, right? And over here, when you assign these numbers 25 and 24, and when you look at this, you would think that, okay, this is going to be the hypotenuse, right? Because that is how it looks. But it's not going to be the case here. And you will have to draw it in this way. This is R, and this is going to be point Q, and this is going to be 25, because mathematically it will not fit, right? This is going to be the hypotenuse. So this line PQ will have to be a straight parallel line, or imagined as a parallel line, or not at a inclination. So that is why it is not working here. So if you find the angle now, then it would make sense. Now, if you find the hypotenuse in this way, if you take hypotenuse 25 whole square is equals to 24 whole square plus r square. Or if you went with this way, you would have used 24 whole square plus 25 is equals to 25 whole square plus r square. This was not going to be possible, right? So either with this idea that, okay, this is not the correct right angle triangle, you can understand, or you can either make the triangle in this way. Okay. Either of those will help you understand which one is right. So if you find the answer here, it's going to be a Pythagorean, no, it's not going to be a Pythagorean triplet. So 25 whole square is equals to 24 whole square plus r square. So this is 625 and 576 plus r square. So the answer would
It will be
be
7.
7. It would be 7. 576 is equals to r square. 49 whole, and that implies r is equals to 49. Okay. So this is the
It will
case.
be 7,
All-
sir.
Oh, 7. Okay. So did you understand that, Zeb? This problem? Yeah.
Sir, sir, before doing exercise 10.2 can be do example 2 and 3.
Example 2 and 3. Okay. All right.
Because all the questions here is easy except 9 and
Except what? 9 and
12. 9, 12, 13.
you have not done 9 and 12.
No, 9, 12, 13 are the only hard questions in this. And
9
example
to
2 and 3.
okay. Examples are not hard, but let us take them. Example number 2 and example number 3. Let us take example number 3. Okay, so PQ is a chord of length 8 centimeters of a circle of radius 5 centimeters. P and Q intersect at a point T. Find the length TP. Okay. So basically, we are being told to find the length of the tangent. Can you say that? Length of the tangent? Okay. Yeah, length of the tangent, because it's formed, they are showing that it's forming the isosceles triangle. It's forming an isosceles triangle. Okay. All right. So let us start that. So PQ is a chord. Okay. Now, when we have a chord, this chord will always, if you remember, you need to remember this theorem from ninth standard, that when we have a chord inside a circle, of course, chord is inside a circle, and whenever we are dropping this thing, this line from the center, okay, this line from the center will always bisect the chord because it's going to be perpendicular. Okay. You can draw many chords to a circle. Okay. You can draw a chord over here, and you can still drop a line, and that will be perpendicular because it's going to be the shortest distance. You can take a chord over here and you can drop a line, and this is still going to be perpendicular. So basically, any chord drawn inside a circle will be bisected by by the perpendicular line passing through the center. Okay, that property you need to remember to solve this question easily. If not, then that will become tricky. Okay, so let us proceed with that.
It can go without being perpendicular, right?
If you're measuring the distance from that center to the chord, then that will be perpendicular. You can of course
Why
pass
can't it?
many. You can pass this line, you can pass this line, and many lines can pass through the center and the line. But the line which will measure the distance of this chord and the center would be perpendicular to the chord. Okay, and would be a perpendicular line passing through the center. Okay,
But they
these
haven't
line.
mentioned that in the question, right?
Yeah, let us see if what they have mentioned. Let us look at that. Let us see what we can do here. PQ is a chord of length and circle of radius 5 centimeters. The lengths PQ, the tangents P and Q intersect at point T. Okay. Find the length TP. Okay. Chord of length 8 centimeters and find the length TP. They intersect at point T. Find the length TP. Okay. So PPQ, can we use that? We should be able to use that. Oh, so it is given here also, right? That OT is perpendicular to PQ. See, if OT is perpendicular to PQ, you can only have one case of that being the case. Okay, if that is the case, then you can very easily say that this whole triangle TPQ, this will be divided in two equal halves. You can say that. Okay, if OT is perpendicular to PQ, then there is only one way that it can pass through, then it can pass. Okay, if there is a line.
OT perpendicular to PQ.
Yeah, we are given that OT is perpendicular to OT is perpendicular to PQ because it's an isosceles triangle and TO is the angle bisector of PTQ. So angle OT. What did NCRT do here? Did they use the property from that particular question? Even I had this second method in mind. Mm, okay. See, we need to find this thing, right? Uh, this is what we need to find. Okay. So let us call this X, right? And we need to use and this as Y. They are took it as Y. Let us see. Just a moment. Let me look at
No, but
NCRT
X
Y.
is equal to Y, right?
Yeah, it should be, but it should be because they are both the length of tangents. Then why did we take X and Y? What is happening here? They are calling PPQ an isosceles triangle, and then they are taking TP and no, they are not taking TP and TR as X and Y. They took TR as Y. Okay, they took two X and Y. Okay, okay, okay. Mhm. Okay, so basically we need to find this. This is our X, this is our X, this is our Y, and this is our X again because TP and TQ are the same, right? And we have two triangles here. One triangle is one right angled. One right angle triangle is this, right? And then another right angle triangle is this, right? So triangle TPR and triangle TRQ. These are two right angle triangles. And if you apply Pythagoras theorem in triangle TPR, that would be x square is equals to y square plus 8 whole square, right? Not 8 whole square. It would be PR.
Yes.
Wait a second, my pen is not working. Hmm, just a moment, let me look at the solution. What are they even doing? Why am I getting confused? See, there is this one question that we have that will help you understand why we will use that.
OT is a construction.
OT is a construction, that is true. Let me take this question and help you understand this. Wait. See, in the question, let me show. This is question number, I think, 7. Question number 5 from NCRT. Okay, this is question number 5 from NCRT. And then also, there is this one figure that we used to prove question number. Yeah, okay. Let's look at this spokes of wheel. Okay, look at these two situations here. Prove that perpendicular at the point of contact to the tangent passes through the center. Okay, we were hesitating to use this property, right? PQ is chord. So I was saying that this line OTR, this line OT is perpendicular to PR, PQ. So OT bisects PQ. If OT bisects PQ, we can simply say this is 4 centimeters, this is 4 centimeters. And we know that, and we can very easily find the length of the tangent then, okay, through some because these guys used this particular thing here. If this is 4 and this is 4 and this is x and we will use this y. You can see in the solution also they were using proportionality to prove that is the case, but let us look at these two questions. So prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. Okay, now look at these lines here, all these lines that you can see. If you rotate this circle, if you take this forward or if you take this backward, okay, you can see that every line that is touching the tangent and the circle, like every line that is perpendicular to the tangent, that is passing through the center, right? Can you observe that thing here? If we have a circle with us, okay, prove that the perpendicular at the point of contact to a tangent passes through the circle, passes to the center of the circle. So if we have this as center and we have a tangent over here, we know that this is always going to be perpendicular. This is the theorem that we have studied, that CP is perpendicular to PQ. But we also have to show that this CP passes through center. I mean, that's kind of that's kind of obvious because this C is, of course, is the center. Only then will this line be perpendicular to PQ. Because if you extend this line again over to this whole side, this whole AP is going to be perpendicular to the, see, if CP is perpendicular to PQ, then if you extend CA, which is passing through the center itself, it is going to have to pass through center. There is going to be no other way to say that CP is perpendicular to PQ and C is not the center. Okay. Is it making sense, or am I confusing you guys, or are you already confused? What is the case? Come on, someone give me an answer, man. That's
I
a lot of
am
silence.
already
It
confused.
is, it
You're
is.
all. It is confusing. Okay. Okay. Let me take a break and think how I can explain it to you. Wait a minute.
The
Mm,
the for the same question, I wrote different proofs.
this prove that perpendicular question.
Yeah,
What was your proof? Read it out once. Let me listen to it and see what I can, if I can help in some way with
sir, can I
that.
draw the figure?
Yeah, yeah, sure. Draw the figure.
So we take x as the we take xd as the perpendicular to tangent.
XD as the perpendicular to the tangent.
Yeah,
Mm-hmm.
and we say
Oh,
xd is
okay,
we
okay.
say
You're going to use radius, right? Yeah. Okay, okay. Go ahead, man. Go ahead.
yeah,
Mm-hmm.
and we say xd is the radius.
Mm-hmm.
So x becomes the center. Therefore,
Mm-hmm.
x is equal to O. So xd is equal to
Mm-hmm.
O.
Yeah. Mm-hmm.
So xd passes through the center O.
Okay, right, right, exactly, exactly. When we are talking about, when we spoke about theorem 6.10.1, when we spoke about theorem 10.1 here, the tangent at any point to the tangent at any point of a circle is perpendicular to the radius to that to the point of contact. Okay, this line is actually the solution to our problems here. That when we are measuring this, when we are talking about this perpendicular thing, this perpendicular line, this perpendicular, we just call it perpendicular because it is obvious that it's a line. Okay, this perpendicular line is going to is passing through center. We are taking this perpendicular from the center. That is why when we are being told to prove this is radius, where does radius pass from? From the center, right? So when if someone is telling us to prove that the perpendicular at the point of contact to the tangent to a circle passes through the center, when we are taking this when we are taking this point of contact to a tangent, how do we join this point of contact? Point of contact is joined through the radius, right? This is the radius. CP is the radius. Now, if you extend this line towards point P or towards point A backwards, this is both going to pass through the center, right? This line is going to pass
Yeah,
through center. And what kind of line is that going to be? It's going to be a perpendicular line, right? And this is what they are kind of saying to us, that the perpendicular line, this is the perpendicular line. The perpendicular that we are talking about in the beginning, point of contact and the perpendicular, is already passing through the center because it is the radius. This is already the radius, and where does radius go from? It goes from the center. Is that making sense now? Saad and Zeb, let me know. I will clear it out. I promise I won't confuse you anymore. I know that got confusing. Let me know if it is clear. If not, let me clear it.
Sir, can you explain it one more time?
Okay. Saad, what about you, man?
Sir, not so well.
Okay. All right. So when we are talking about this thing, theorem 10.1, the tangent at any point of a circle is perpendicular to the radius to the point of contact. So when we are talking about this, Let me copy that question into this part. Okay, this is a question that we need to prove. Okay. All right. So this question is asking us to prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So first of all, let us draw what is perpendicular at the point of contact to a circle. Okay. Now, this theorem that we just studied, it told us that the point of contact, the tangent at any point of a circle is perpendicular to the radius to the point of contact. Okay. So this particular sentence here is perpendicular to the radius to the point of contact. What is point of contact? Point of contact is the point which is common both to the circle and and to the tangent, right? This P is common to both circle and to the line. Now this P is going to be perpendicular to the line and the circle. How is it going to be perpendicular to the line? It is perpendicular because we are taking that particular line from center to P. Okay. This is radius. When we are drawing any line from center, it is going to be called radius. This is radius. This is radius. This is radius. Right? This is also radius. Now, if I make a tangent over here, this is going to be perpendicular. This is going to be perpendicular if I make a tangent here. This is going to be perpendicular if I draw a tangent over here. Right? And all of these lines are passing through what? Center. This line is also passing through 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 the center. Right? Is it making sense now?
Yes, sir.
Right? So it's sort of the given thing that we are taking with us, that the point of contact itself is made by joining the point of contact joins to the circle through the radius. Okay. And that is why it's called a perpendicular. And since it's joining through the radius is what? It's the distance from center, right? Radius is distance from the center. Distance from center. So if you are measuring this and this is coming out to be perpendicular, it will have to pass through the center, right? It can't take this deviation and go. It will have to pass through the center. All right. So that's the case here. What's the time? Okay, we are out of time also. All right. Let us take this in the next class. It has been confusing enough. Let this all settle in the head. When I'm a little confused to explain more right now. Okay.
Sir,
Mm-hmm. Sal?
are you free? I need 10 minutes.
Sure, we can.
Mm.
What does it? Do you want to talk alone?
Yes, sir.
Okay, just a moment. Do you have any doubts, sir? We will take this up in the next class, anyhow. So I have a chat. Yeah. Okay, subject. So, do you have any doubts, sir? Of course you do, but we'll take that up in the next class.
Okay, sir.
Okay. All right. You can leave the class, Zeb. Me and Saad will have a conversation and then we'll end the class. So we will take this up in the next class and I will try to make it as simple as possible to understand
Okay, sir.
since
Thank you,
you
sir.
also got confused. Okay. Take care. All right. Yeah, Saad. What is it?
Sir, I have doubt in chapter 3. Like, I have test tomorrow. So
Mm-hmm.
I'm just in chapter 3, exercise 3.3.
Exercise 3.3. All right. Just a second. It's polynomials, right? Linear equation in two variables.
Yes, sir.
All right. How many marks is the test for?
10, I guess. 10 to
10. All
20.
right. Okay. Okay. No worries. Okay. So, exercise 3.3.
Yes, sir.
Question number?
Question number 1. And then
Question.
the 2 also. Not 4.
Question. Solve the following pair of linear equation. The one with fractions. Is that the question?
And solve the following pair of linear equations by the elimination and substitution method.
Okay.
I
So
just want
which
to
one?
recall them.
Recall it. Okay. All right. Let us take
How
the
to do it.
fractional question here. X by 2 by, so x by 2
Okay.
is x by 2 plus 2y by 3 is equals to -1, and x minus y by 3 is equals to 3. All right, let's solve this both by substitution and elimination. Substitution, first of all. Before substitution or elimination, you need to make these two equations in standard form, ax plus by plus c. Okay, these should be integers, not fractions. Okay, over here, what we have is 1 by 2 into x plus 2 by 3 into y is equals to -1. And this is x minus 1 by 3 into y is equals to 3. Okay. Over here, a, b, c and a, b, c should be integers. That is much more preferable to us.